Welcome to this Matlab tutorial. This Matlab tutorial is going to be on the basic syntax of Matlab. So I've already opened Matlab, and this is generally the screen that you see most of the time. So the big main window is called the command window. You'll be working here most of the time. You can view your variables in the workspace on the bottom left, and you can view your current directory on the top left, and so that will tell you where in the file system you currently are. So if you want to open a file from there, you don't have to type in the absolute path. You can just type in the file name directly, or if you save a file, that's where it will go. So we call that the working directory. And you can change the working directory to keep all your projects separate. So you can go into the path up here and type in another path if you want to use the path for your particular project. So in Matlab, there are three basic types of numbers that you'll be working with, or variables, that are all actually matrices. So you have scalars, which are just plain numbers. You have vectors, which is kind of like a list of numbers, and then you have matrices, which are tables of numbers. So as I've mentioned before, in MATLAB, all these variables are represented as matrices. So if I do something like x equals 5, you see that in a regular programming language, you might just think of this as x equals 5. But I can do something like check the size of x, and I see that it's actually a 1 by 1 matrix. I can create a vector. Okay, we use square brackets, and you don't need commas, but I'm going to use them. And so that creates a vector with the elements 1, 2, 3. So if I do size of v, I see that it's a 1 by 3 vector, or you can also call it a 1 by 3 matrix. So this brings up some other interesting points about how MATLAB syntax works. I mentioned that you don't actually need the commas. So we can just do that, and MATLAB knows that we want a 1 by 3 matrix with the elements 1, 2, 3. So you also notice that I added this semicolon at the end of the line. And what that does, it's easier to see if I just don't do it. So it prints out the last thing. So if I don't use the semicolon, it's going to print everything out from the previous command. But if I do use the semicolon, it will suppress the output. So that's why I didn't put a semicolon after size v. If I did, I wouldn't see anything. Now we're going to go on to look at matrices. So it's very similar to creating a vector, except we need to have a way to separate each row. So that's done with a semicolon. And I'm not going to put one at the end so we can see the output. And so what that does is it creates a 2 by 2 matrix with the elements 1, 2, 3, 4 in a variable a. Right, if I do size a, it's 2 by 2. So those are the two things we've learned about initializing vectors and matrices, is that you can use commas to separate columns, but you don't need the commas. You can just use spaces. And to separate rows, you can use semicolons. Another thing is that when you're when you're working with matrices and vectors and you're multiplying them and stuff like that, the dimensions of the vector are very important. So typically, you'd work with a column vector, not a row vector like the one I just created. And so we can easily transform the previous vector, which was a row vector, into a column vector using an apostrophe. And so that does a transpose. And so you see now that V used to be a 1×3 vector, and now it's a 3×1 column vector. You could have also initialized it using semicolons, of course. Okay, so the next thing I want to talk about is how you can access elements of a matrix. Typically, that's done using parentheses and then indices and commas in between. So if I want to, in general, access the ith row and the jth column, it would be A parentheses I comma j parentheses. So if I want A11, for example, I would do that. If I want A12, and so on. A21. Another interesting thing you can do is access a vector within a matrix. So let's say I want the first row of the matrix A. I can use the colon syntax to get the first row. So I'm going to put a 1, or I choose the row, and then I'm going to put a colon in the choice for column, which means return me all the columns in row 1. So if I do that, I get 1, 2, which is the first row of A. Similarly, I can use the colon syntax to get an entire column of A. So let's say I want to choose the second row, or sorry, the second column. So let's say I want to choose the entire second column. I would do that. And of course, if I do a colon in both parts of A, it'll just return me the entire A. So let's create a bigger matrix now, so I can better illustrate my next point. Alright, so I just created a 4×4 matrix. So the colon syntax can also be used to access ranges. So if I look at A, it's 1 to 16. If I want the part of A that has, so a submatrix that has the 6, 7, 10, 11, I could access that part by choosing the second and third row and the second and third column. If you've programmed before, usually when you're working with vectors, matrices, arrays, they're 0 indexed. In Matlab is 1 indexed. So A11 returns me the first element. It's not A00. One other cool thing that we may use later is the colon syntax can be used all by itself. It actually just creates a range. So if I did something like 1:10, gives me back all the numbers from 1 to 10. And so say I want to assign this to a variable. Let me check the size of W. So that creates a row vector with the elements 1 to 10. It's simpler to do than typing 1 through 10 manually, right? And so just to extend this a little bit, we aren't limited to only scalars, vectors, and matrices in Matlab. You may have heard of a data structure called tensors. And so those are multi-dimensional matrices. So it's not a table, it's more like a cube or a hypercube. So you can, instead of having a 2 by 2 matrix, you can have a 2 by 2 by 2 tensor.